This lesson is on adding and subtracting rational expressions with unlike denominators. Once again, we're going to think back to when we learned about fractions. We had 1/6 plus 3/12. We would first look to see if our denominators are the same. They are not. And so we would have to think, what is the smallest number we can multiply one of these by, or both of them by, to get the same denominator. Because we can only add or subtract if our denominators are the same. And we know that if we multiply 6 by 2, we'll get 12, so then they'll be the same. So then we multiply both the top and the bottom by 2, and that's because 2 over 2 is 1, so when you multiply anything by 1, it is still the same, so we're just writing 1/6 as something that looks a little different. We still have plus our 3/12, so then we would multiply these, and we get 2/12 plus 3/12, and that equals 5/12. Right? So if our denominators are not the same, we are going to multiply by something to make them both be the same, so we can add or subtract our numerators. Right? We have a vocab term. The least common multiple is the least number that is a common multiple of 2 or more numbers. So if we think back to that example that we just did, we had, I believe it was 1/6 plus 3/12. So the least common multiple when we're dealing with these rational expressions or with fractions is going to be, we're looking for the least common multiple of our denominators. So we knew our least common multiple would be 12 because that is the smallest number that 6 and 12 have in common. So then we took that least common multiple of 2, we took 2 over 2, and multiplied that by our 1/6, so that our denominators then would be the same. And we're going to use that same idea with rational expressions. Alright, now we're going to find the LCM, or least common multiple, of 15a squared b squared and 24a squared b. Alright, so first we're going to look at the numbers. Alright, and we want to find the least common multiple of 15 and 24. So I'm just going to start writing out the multiples of 15. So we have 15, 30, 45, 60, 75, 90, 105, 120, we'll do one more, we'll go up to 135 there. Now we're going to look at the multiples of 24. So we have 24, 48, 72, 96, 120, and I can actually stop there, because if you see, we have 120 up with the 15, and we have 120 with the 24. So 120 is going to be our least common multiple of our 15 and 24. Now we have to look at our variables. Okay. Notice we have a squared in both of them. So the only multiple of a squared that we need to look at is just a squared, because since it's already in both, we are not going to have to multiply by any a's to get them to be the same. Now we got to look at our b's. So we have b squared and b. So here we have b squared, and then the next would be b to the 4th, and then b to the 6th. Alright, so we're just adding our, see how we're changing our exponent here. So that's how we find our multiples of our expression, or our variables. So then b would be b squared, and we can actually stop there because we see a b squared here and a b squared there. So our least common multiple of 15a squared b squared and 24a squared b would be 120 a squared b squared, right? Because that is the lowest number that 15a squared b squared and 24a squared b have in common. Right, now we're going to find the least common multiple of x squared minus x minus 6 and x squared plus 2x minus 15. So for x squared minus x minus 6, we are going to factor. Right, so if we make our chart over here, we know that we have x and x going on the left, 3 and 2. We know that one of them has to be negative to get our negative 6, and since x in the middle is negative, that means our bigger number has to be negative, so it's going to be a negative 3. So we have x minus 3 and x plus 2. Okay. And then we are going to do that same thing. We're going to factor our x squared plus 2x minus 15. We know that x and x is going to go on the left. And then we have 5 and 3. One of them has to be negative because 15 is negative. Our middle term, 2x, is positive, meaning our bigger number has to be positive, so our 3 is going to be negative. So we have x plus 5 and x minus 3. Now we see we have x minus 3's in common, so our LCM, we're going to have 1x minus 3, because that's what they have common. And then we have to multiply by the other terms that are left. So in here we have x plus 2 and x plus 5. Alright, so our least common multiple is going to be x minus 3 because that's what they have common. And then you multiply by what is left, and we have x plus 2 in the first and x plus 5 in the second. Alright, now let's get on to adding and subtracting our rational expressions. We have 7 over 3m plus 5 over 6m squared. So if we look at our denominators, they are not the same. So, now that 3m equals 3 times m, and 6m squared equals 2 times 3 times m times m. So that's just our prime factorization. We see that we have a 3. We have a 3. There we go. And an m in common. Okay. And so to get our 3m to look like our 6m squared, okay, we're going to have to multiply by 2m. So our least common multiple would be 6m squared, because that's what we're going to try and get them both to be. So we have our 7 over 3m times, we need 2m over 2m, because again we need to multiply the top and the bottom to keep our fractions the same, plus 5 over 6m squared. Now when multiplying, we multiply straight across. So we get 14m over 6m squared plus 5 over 6m squared. Our denominators are now the same, so we add straight across. So 14m plus 5 over 6m squared. And we cannot simplify it all, so there would be our answer. Alright, let's do one last example. We have s over s plus 3 over s minus 4. Alright, and first we check to see if our denominators are the same. And they are not. S plus 3 and s minus 4. We cannot simplify those down at all, find any prime factorization or anything. So our least common multiple is just going to be s plus 3 times s minus 4, because they have nothing else in common, or actually they have nothing in common, so we have to multiply them together, and that is our least common multiple. So our s over s plus 3, we're going to multiply that by s minus 4 over s minus 4, so that our denominator equals s plus 3 times s minus 4. And we have plus 3 over s minus 4, and multiply that by s plus 3 over s plus 3. And once again, we want our denominator to equal s plus 3 times s minus 4, which is why we multiplied by s plus 3 over s plus 3. Now let's multiply straight across. We have s times s minus 4 over s plus 3 times s minus 4 plus 3 times s plus 3 over s minus 4 times s plus 3. Now that our denominators are the same, we can add the tops. So we have s times s minus 4 plus 3 times s plus 3 all over s plus 3 times s minus 4. Now we're going to simplify, so we're going to distribute. So we have s squared minus 4s plus, distribute our 3s plus 9 over s plus 3 times s minus 4. Then we combine our like terms. So we get s squared, and we have s's here, we combine those, minus s plus 9 over s plus 3 times s minus 4. And on the bottom you can just leave them in the parentheses, you do not have to FOIL that out. And that would be our answer. Alright, so let's do a quick review. Step number 1, we find our least common multiple. Step number 2, we multiply the top and bottom, so the numerator and denominator, by the same thing. And that's because when you have like 3 over 3, that's 1. So if you multiply the top and the bottom by the same thing, you're multiplying essentially by 1. You're just rewriting it, making it look a little different. So we multiply the numerator and denominator by the same thing to make our denominator equal the least common multiple. Okay, then step 3, add or subtract our numerators. Okay, and then step 4 is we simplify if we can.